Back to the N4 Learning channel. Someone has asked me about the rotation load sequencer and to reset it via the logic, so we don't do a manual reset. So we wouldn't go here, actions, and reset failed load and pick the load, and we wouldn't do it via the graphic. Let's just open up another page there and the graphic here, and we wouldn't do it via pressing that and selecting the load. We would automatically reset both pumps A and B. So to do that, I used an enum writable and I linked the set in there. Let's show you how that works first of all. So enum writable, and what I did is I did my pin slots and I took out the in 16 and 10 and just exposed the set here. And then to get that text, I basically went into there and there and there, added a 0, which I know is pump A. So I'll just put reset there, reset pump A. Now I know we jumped to 2 to reset pump B, and if there was any more it would be a 3 to reset pump C, and so on, a 4 to reset pump D. But we're not doing any, we're only doing A and B, but I'll just add them in there anyway. Okay, okay, save, back out, actions, set, and then you can select what you want. So we'll leave it at A, and that's all I've just done here with that particular one. In fact, I'll delete that out now and put that in its place. In 10. And put that into set there. Rename reset pumps. If they are pumps, they could be anything, they could be boilers, whatever you wanted. And then all I've done here, because we've only got 2 pumps here, all I've done here is set this enum switch to reset pump B first, so if I get a true, and the 0 false anyway will reset pump A. Let's put this into fault. At the moment we've got a feedback delay of 30 seconds, so I'm going to lower that so we're not waiting 30 seconds for the pump to go into fault, so 5 seconds, but normally you would have 30 seconds, or how long it takes for the flow switch or the pressure switch to enable, and you want to just go a few seconds over that. So this should go into an alarm, and then this one should go into alarm, which they are. So let's reset this now, actions and fire. So we're resetting pump B, so we're sending a 2 to that, and resetting pump A, and we're sending a 0 to that, and nothing's resetting. So we must have something wrong with our writable. Let's see what we've got here. 0 pump A, 2 pump B. Okay, 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 save, go back. That's our set into there. That's our setting it to a 2. That's our output. And if I go into here and actions, reset failed load, I can do it from here. A, actions, reset failed load, B. So there's no reason why it can't do it from here. I know why. Know exactly why. I've done that wrong. That needs to go into there, into the set. So that was me. Completely wrong. But now we've put it right. So it's good that this happens. You know where we've gone wrong. So let's disable that. Let's enable it again. So this we're going to fault. And then this one we're going to fault. And then we do a fire. That's B, reset. And then when the fire goes off, which I've done it for 10 seconds, 10 seconds is too long, you only need 5 seconds. And there's your A done. So let's just adjust that to 5 seconds. Reset. So that's your global reset. So what you could do here is we could, when we actually ask the schedule to run, so let's just put this into fault again. Because we're not getting a feedback on here. Feedback, where are we? Feedback here, A and B. But it's going into fault. That's the reason why they're going into fault. And then when we be actions, emergency inactive. Or let's just set that to emergency auto. And actions set to false. What we can then do is link that into there, the one shot. So when we enable this block, these faults were clear. So set, true. So we've cleared B, and A's now cleared as well. B's naturally gone into fault because there's no feedback. So let's just show you how that works to stop it from going into fault. So I'm taking the output from there, feeding it into there, and that into there. Normally what your feedback would be for your A and B would be a DP switch. Maybe you've got a DP switch on A and a DP switch on pump B, which is fine. But if you've only got one DP switch, you would put them into an OR gate. So what you would do there is find an OR gate. And you would have your DP switch for A and B going into there. So let's just cut that feedback out there and feedback there. Put that into there and put that into there and put that into our feedback A and feedback B. Reset this. So that's them both reset. Now they won't go into fault now, but if we just disconnect that or leave it like there and just turn that to actions set to false, do it that way, and then actions set to true. So pump B is currently running. It's not gone into fault because for true it's coming into there and feeding back into there. So, but if it went faulty, so let's make it go faulty. So we're just going to cut that. Now it's gone into fault and pump A is running. Pump A won't go into fault because the feedback of it is in there true, so it's happy with that. But if we take that feedback out as well, pump A's now gone into fault. So they're both in fault now. We don't need that. And we can actually put that to B and that to A. Now what I would normally do, if we've got a DP and only, say we've got a DP for each individual one, I would have one input going into A and one input going into B. But if I've got an input, a DP for both pumps, I would let me just make a DP. So that would be your input, for example, from the DP sensor, the flow sensor. And then in this case, I would do some AND gates. And I would do pump A, for example. And let's just tidy this up in the respect we put DP there, and we put enable there, and then we can even do the fault in case we get a fault signal from that pump. Fault in there, and then I would put my DP into there. Let's expand this because I've got the fault in there now. The enable for pump A, I would naturally put, I'll take that out and I'll put that into the enable there, and then new Boolean writable, and this is a fault from the inverter or overload, doesn't matter what it is, and we always want that to be true. Let's just not do emergency order, let's just do set true. If it wasn't true and it's the opposite way round, you would just use a NOT gate, so you'd put a NOT gate in here like so, and you reverse the signal. So if it is false and it goes to true on a fault, that's what you would do there. So we'll leave that one in there now and put that into fault. So that's pump A done, and then I'll just duplicate that for pump B. Now the reason that's come up with a 1 is because it can't use the same wording, hence that's why I've just put a, see we've got pump A already here, so hence it's done a 1 there at the end, because you can't have the same, on the same wire sheet, you can't have the same label or the same point name. So we put our DP into there, we remove our enable there, and we'll take our enable and we'll put it into there, and then that was a fault for pump 1 for pump A, PA, duplicate, fault PB. Again, these are just going to be inputs. I'll just rename that FAU A, or healthy A, because I'm giving a true out there. Healthy A, duplicate healthy B, put that into there, and take that, put that into there. So now if these go faulty or the DP doesn't work, then you will get the alarm and it will change over. So let's just move that, let's take that, what we did in an old project 2 or 3 times before this, 2 or 3 episodes before this. So we'll make it inactive, so we'll set it to a false, and then we'll set it to enable, so set to enable. The alarm's clear, pump B is running, pump B is now gone into fault, so pump A and pump A is now gone into fault. Now let's put the DP on this time. Oh, I'll tell you what, let's do it as it would normally be. Actions, set this to off, give me a bit of time to put the DP on, so let's put 10 seconds on there. And really we could do with resetting this before we actually start the pump. So what we're going to do here is we're going to put a Boolean delay in here. So we reset the system before we start the pump. So we'll put an on delay of 5 seconds we'll do. We'll put that into there, and we'll go on delay of 5 seconds. So even though I'm giving it an enable, it won't put the output until 5 seconds, which is this output here. It gives us time to reset everything before we start the system. So actions, set, enable. So that's still false at the moment there. Everything's reset, and then that's gone to true. I set that to 5. It'd probably be better maybe 6 seconds, because this timer here is set to 5 seconds. In fact, let's expose that on the pin slots. Let's bring out the time there, and we'll do the same with this one. We'll bring out the time on delay, and we don't want that. Actions, set, false. So now we're going to start it again. True. We're going to make the DP this time. It was just easy to do emergency active for me. So that's running pump B, out B there, and we want to just rename them, we can do. AX slot sheet, out B, pump B, pump A, and the feedback time, pump, so feedback pump A, control key C, feedback pump B. And then we can also do the time, which is what I was, one time pump A, one time pump B. Go back out. So they are both in alarm. Why did they go into alarm? We reset it. Oh, what an idiot. It opens if I put the pump B into feedback there and pump A into feedback. Sorry about that. Set to false. Set to true. We've got the DP on. We've done the reset. We've enabled the scheduler. Like I said, that wants to be about 6 seconds, because if we fire at 5 seconds. No faults. Pump B's running. Pump A isn't. Now I would have expected to see pump A run, so it could have been this 5 seconds here. In fact, I'll turn that down from 5 seconds to something like 3 seconds. Now let's try this. False. Set the enable to true. So that can be on a time clock or whatever. So with everything's reset, I'm expecting this pump to start, and it hasn't. It started that pump. So why has it started that pump? Because we're on interval, one time. So we start the shortest pump first. Actions, set, false, set, true. Now it's started, and it's still running that 45-minute one instead of a 23-minute one. And there's no fault. So rotation mode is runtime. I'm putting that into pump A, 23 minutes, that into pump B. So why are you still starting that pump? Rotation order A and B. Outputs to required loads 1. And you want to run the lowest pump first. And you're not doing. Why are you running that pump? Let's just put pump B into fault. So now we're running pump A. This is another thing as well, we don't want to be sending a signal out. If it's in fault, we want that to be false. So we would tie that signal up to an AND gate. Because we don't want to, if that's going to direct it to an output, we don't want to start that pump. We don't want to still keep the enable. I mean, if it's faulty, it's faulty. We want to turn it off. Let's just do that. Let's just get an AND gate. Take that out of there. Put that into there. And put the fault now into there. And then put that back into there. Rename PMP B. Duplicate PAP A. PMP A. Take that out of there. Put that back into there. Put that into A, which is your enable. And take the fault status for that one and put that into there. So that was still run. So these are basically my outputs that I would put. So let's just do a output to IO pump A. Don't want to do that. Control key C. Delete. You probably keep seeing the save come up as well. The reason for that is when I'm writing logic, I normally set it to save every 30 seconds. I'll show you how to do that. Let's just change that to enable, disable. And duplicate that one. Pump B. Okay. So let's show you where I do the enable, disable, the saving. Services. Platform service. 30 minutes. Station auto save frequency. Normally that would be set to 24 hours. I put it to 30 minutes. So every 30 minutes it will go and save itself. And I prefer to do that so that once I've finished I put it back to 24 hours. But in case anything happens, power cuts, something stupid, I've saved at least 30 minutes, well, I've lost 30 minutes of work if it reboots and I've not saved it. Especially on an Edge 10, because we're working on an Edge 10 here. It's a bit different on the Mac 36NL. You can power off a Mac 36LR while you're working on Logic, and everything's back to normal when you power it back on again. An Edge 10 doesn't seem to do that. It wants saving. So if you're working on an Edge 10, you're better off having it save itself every 30 minutes or even every 15 minutes. So we've still got the issue of that pump running all the time, even though I've set it all to 1 time. So let me put that into false. So we stopped it. We know pump B was an alarm because of that. Let's put that back to normal again. Let's enable it. So we're clearing the alarms. We haven't started it yet. We've got 6 seconds. Now we've started it. And it's still running pump B, which is the most hours. So there's got to be something else in here that's actually starting that. Lead load B, next load A. Well, the next load A is going to be after 168 hours, according to that. So the lead load is B. So it's not really taking into account the bloody rotation mode. It's taking into account the load, so I can manually rotate it. So there we go, we're running pump A now and not B. We already automatically reset it. So we've got the manual command, which we'll never use, and enable and disable the outputs. Right, what should we do now? We've got our feedback delay done. Rotation mode runtime. Required loads 1. I presume we could add another pump in, so we're off 3 pumps now instead of 2. That's going to get a little bit complicated on the reset bit then, because I've also got to, at the moment it's easy doing this because we're sending a 2 and then we're sending a 0. If we're doing a reset of a pump, adding another pump, we're going to have to send a 0, a 2 and a 3 within 3 seconds. So that's going to get a little bit complicated. I'm just wondering how I would do that, thinking while I'm talking. Alright, let's add another pump in because I'll show you how to do this change of state. So we'll start with a blank block. Pump. I would normally just copy that, but that's no good to you. This is a learning channel, so you need to know how I've done it. Actions, set that to false. Now I'm going to find that in here, which is there, and I'm going to go to my extensions and a discrete totalizer. I'm going to put that into there. So I've got a discrete totalizer in there now. I'm just going to tidy up this and take that in 16. You don't have to do that, it's just my preference. I just like to keep things nice and tidy. So sorry, I never told you. I'm pressing composite there then now. So I'm right clicking the pump C, going down to composite, excuse me, expanded pump C, expanded discrete totalizer, moving that slightly across, and I'm going to go for the change of state count, so how many times it stopped and start, and elapsed time. And then I'm going to change this. In fact, let's just disable this. And I'm going to change this to 3 outputs now. And take output C into there. Let's just change the AX slot sheet and let's now put in pump C and feedback pump C and runtime pump C. And then we need to do this, so we can just duplicate that and pump C, and we can duplicate that pump C. Put that into there and take the true and put it into there. Now we want a fault. In fact, you can duplicate both these at the same time. There's no. It's going to be fault PC healthy C. Duplicate that C. So we've still got 1 DP only. So we can put that into the DP. Be enable. And the fault. Try and just tidy these up a little bit. So these would just be normal inputs into the system. You won't be, there won't be control points. They're just from your I/O. Your inputs. Okay, well, it's tidy-ish. So we've got A, B and C. We've got our outputs there. Don't know why the hell C is enabled when I haven't even got the scheduler on. Oh yes I do. Or don't I? No I don't. Because it's coming directly from that. So let's just put the scheduler on. It'll be just something in that block. Turn it back off again. All disabled now. So 10 seconds feedback delay. Let's put them all in fault. Let's just change that to a 5-second feedback delay. See how this runs now. Set to true. So we do the reset, which is only resetting A and B. Oh, we haven't got the feedback for C, have we? I missed that off last time. So pump A is running. We're naturally not going to have a fault. So let's put pump A into fault. In fact, let's stop the DP. Pump A into fault. Let's activate the DP again. So now it's got pump B's running and it's got the DP. It's all happy. we're not in fault. We'll take the DP off. Pump B is going into fault. Put the DP back on again. I wasn't fast enough. I wasn't fast on the 5 seconds, so they're all in fault now. And yet you've still got all these enable, so even though it's in fault, it basically sends an enable out, which we're okay with this because we've linked these faults now into not sending the enable, but we've still got 3 outputs at the moment all enabled, and yet they're in fault. So I think to deal with that one, we're going to have to use a status demux, I would have thought. So status demux, where are you? You're there. PA. Put you into there, and we can put you into there. And there's your alarm. So take out all this rubbish. Well, not rubbish, but what we don't need. And that is an alarm, so we'll put you into there. The and. No, we need to put a not gate there. We need to reverse it. Because true is alarm, so let's just put a not gate in there. Just put A L M P A. Now we can put you into there. Now you're not enabled. Duplicate. That's going to be PB. And that's going to be PB. Yeah, PB. Pump B. And we can take you and put you into Boolean in. And put you into there. And then the same for pump C. Take the C, put you into there. Rename you. Rename that. Put you into there. So just to recap, that's enable, that is fault, and that is status alarm. View AX slot sheet, enable, fault, and alarm stat. Oh, that actually wants to be, because it's going to be a true, so it wants to be a healthy. And alarm healthy. And I would do the same with all them, but I can't be bothered. Right, so nothing's on. Let's switch it all off. So set and go to false. Now I know pump C is not going to clear because I've not wrote the logic yet for resetting pump C. So we know we're only going to reset pump A and B. So it's not going to be no surprise to us that pump C doesn't reset. So we're not asking for it yet. Now we are. pump C hasn't reset, which we knew that. Enabled. So let's put that into an alarm. Emergency inactive. So yes, it's gone off now. Emergency auto, and that's gone off. And I wasn't fast enough to do the other one because I've only got 5 seconds feedback delay there. Let's change that. Give me a bit of seconds to play with, and let's do that again. Actions set to false. Actions set to true. So we're resetting the alarms apart from C. We know that's not going to reset. We've already said that. We're not running there, so actions emergency active. So pump A is still running. The others are off. Now we're going to fault the DP. Now I'm going to emergency active again. So pump B is running. Pump A is no longer, even though you got a true signal, we are not running pump A. This is what's going to our outputs here. So let's just go to kit PX and let's go to our Boolean image. I didn't want to do that. Okay, it's PX. So I wanted to put some sort of label around that, but what would we do it this way instead? Text blocks, outputs, true, font bold, 16, and make it green. Save. Outputs. Save. Probably better making it white. On that background. Underline it. Why not? So we know that's our outputs. And if we move that across slightly and put that there and duplicate that and type in inputs, won't put the underline on that one. It gives you a good idea of, so that's our IO inputs, that's our IO outputs, inputs, outputs, and everything in between is our logic. Not that we're using that, but right, so we're true. We've got that in fault. Set that to false. Let's set that back to true. So we're doing a reset on everything, apart from pump C at the moment. And we're not going to have any faults because we've got a DP here. So we've made our DP. We put pump, put that into fault. Pump, what pump's running at the moment? Pump A. So let's put pump A into fault. Now pump B is running, and it will stay running. We haven't got an output there. We've got an output there. We haven't got an output there. Put pump B into fault. Pump A is now running. No, none of them are running because they're all in fault. They're all in fault. Good. So now what we've got to work out is how to do the reset for pump C. What I was doing with that, I was going to take it out of emergency auto, and I'm going to turn that off and try and work out how I'm going to do the reset. Let me have a think about this one, because we need to send a couple of values to that now. Well, we need to send a 0 to it, we need to send a 1 to it, and we need to send a, no, not a 1, we need to send a 0, 2 and a 3 to that output via this enum switch. Just I got that ready, so reset pump C, output 3, 0, 2 and 3. So I've got to send a 0, 2 and 3 to it. Right, let me have a think. So I've had a thought, and there's a couple of ways I think I could do that. I could either have 3 resets, one firing, then another one firing, and then another one firing, sending a 0, sending a 2 and sending a 3. I could use a ramp into the true signal of the reset A and B, and I can ramp 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, which would then change that to reset them all. And I'm trying to think what would be the best. The ramp is only using one block. Not that it makes any difference. Probably be easier doing the reset, you know. Sending the reset with the enable, and then sending the other reset and the other reset. Let's try that. I'll work on that and I'll come back to you. Right, I've done that. I don't know if I like it, but I've done that. So let's put this into false. So off. Emergency auto. Action set to false. Actions set to true. So we're doing a B, now a C, and when it all stops, it'll be back to A. So that's your reset done. And they're going to go into fault because we haven't got our DP on. So that's going to go into fault. Then B is going to go into fault after 10 seconds. And then C is going to go into fault after 10 seconds. So let's put our DP on. Actions set to false. Actions set to true. So we're firing this and we're firing that. So what we've done is we've took the out not from there. So once this is finished firing, this out not is true. And then I set this for 6 seconds. So that's not going to send an output to that because that is going to be false when this is actually working. When that's true, that's false. So, but once this is switched off, we then makes that a true, and then this is still enabled because it's enabled for 3 seconds more than the reset A. So that would be true. So that would be true, and it would send the reset for pump C there. And then when this goes off, which it is at the moment, it's resetting pump A, so it's just sending A back into there. So while this is on, this resets pump B. When this is on, this resets pump C. When this is off, it sends the A into there, and that's off A, so that's your pump A. So that's your A, B, C all done on adding these 3 blocks here, reset C and reset C. It works. Just wondering if there was a simpler way of doing it than that. Maybe just ramping up, having a ramp going over time, 1, 2, 3. I don't know, but it works. So there will be a simpler way of doing that, but that's to reset on the enable. I think that's it for this one. I think we've exhausted this block now of what we can really do. The other stuff like the manual rotate, that's just an easy one. That's just an on and off. So if we go to disable that, set that to off, actions, set that back to on, we know we're going to be okay and there's nothing's going to go wrong here. So we decided to run in a minute once it starts. Yeah, pump A. So if I just go numeric writable as an action, set that to false. If I put that into manual rotate and actions just quickly, well, just emergency active, we rotated now to C. So that can just be a pulse. Let's just put that as a pulse. Let's just duplicate one of them. Rotate. Put it to 1 second. We don't need the fire, we don't need the out, we don't need to show the time. And you'd probably be doing it from a graphic, so we actually don't need the in. Let's just show the fire, just because we can. So we're running B at the moment, actions, fire. Now we're running A. Actions, fire. Now we're running C. Actions, fire. Now we're running B. So that's a simple one, the manual rotate. That's not as complicated as resetting load fails. Manual command, well, I presume from the graphic you might want to say I want pump A running over time. So that's another one we could look at. It's just making, so if we right click that, actions, manual command, so enable output A. So what we've got B at the moment. Go OK. And it hasn't done anything anyway. Let's disable actions, manual command. Let's disable B. Well, we disable B, but it still says true. Yeah, you got the null value there now. Not that I've ever used that command. And we've got C running, but according to the outputs, B is also still running even though we've disabled it. So we would have to have our logic into there for the disable bit. Yeah, because we've got a null value there. So we'd have to add a bit of logic in there. If it's null, false. But I'm not too worried about that. That's just, we don't need to go any further, I don't think, in this job, on this particular one. Alright, thank you for watching. If you've learned something, please subscribe. The more subscribers the better. And watch out for the next video. I don't know what I'm doing. I might do series transform. I like series transform. You've probably not seen it before. It's in the Vicron Pro series transform here. No, it's not that particular one. It is series transform. This baby here with the nodes on the history source. Or I might even just show you a site that I've done series transform on. I don't know. I'll see what my next video is going to be when I work it out myself. Thank you for watching. Please subscribe. Speak to you later.